Let's go to guided practice 3. A lobster trap is made in the shape of half of a cylinder. It's constructed from a steel frame with netting pulled tightly around it. The steel frame consists of a rectangular base, 2 semicircular ends, and 2 further support rods as shown in the following diagram here. The semicircular ends each have a radius r, and the support rods each have length L. Let T be the total length of steel used in the frame of the lobster trap. Write down the expressions for T in terms of R, L, and pi. From this diagram, we could see we have for this L. And the length from here to here, that's diameter. We have 2r. This will be 2r2. Then you calculate for this circumference, half of this circumference, multiply by 2, because we have another one here. In other words, these two adding, you will get the circumference of a circle. Therefore, for this T equals 4L plus 4R plus 2 pi R. Look at the 11b. The volume of a lobster trap is 0.75 meter cubed. Write down an equation for the volume of a lobster trap in terms of R, L, and pi. We know the volume equals 1/2 of a cylinder. And for the cylinder, I use VC stand for the volume of a cylinder. We know that it's pi r squared times the height. So we get the 1/2 pi r squared times height. Pi r squared, the height will be this L. Then we will set up this equals 0.75. For 11c, the volume of the lobster trap is 0.75 meter cubed. Show that T equals this. So we got the T equals 4L plus 4R plus 2 pi R. According to this, we can get L. How you get this L? In other words, how you isolate this L? We multiply by 2 both sides. Then you need to divide it by pi, both sides. Then you divide it by r squared, both sides. So we get L equals 0.75 times 2, that's 1.5 pi r squared. Then we will substitute this L by using 1.5 over pi r squared. So we have 4 times 1.5 pi r squared plus 4r plus 2 pi r. So we get the 6 over pi r squared. According to the expression we are looking for, we need to factor this r. So we add r, take out 4 plus 2 pi. Then we organize into this format. We can write down 2 pi plus 4 r plus 6 over pi r squared. Let's go to 11D. The volume of a lobster trap is 0.75 centimeter cubed. Find the dt by dr. We know this t equals this. So we have dt by dr equals 2 pi plus 4 r. We have to do the derivative. Then plus 6 over pi r to the negative second power, we have to do derivative. For this one, that's a linear function, so we have 2 pi plus 4. Then plus, drop this negative down, we have negative 12 over pi r to the negative third power. We organize, you will get the 2 pi plus 4 minus 12 over pi r to the third power. Now go to 11E. The lobster trap is designed so that the length of steel used in his frame is a minimum. Show that the value of r for which t is a minimum is 0.719 meters. Correct to the 3 significant figures. In other words, we are looking for minimum, so we need to set dt by dr equal to 0. In other words, we need to set up this equal to 0 to solve for this r. So we have 2 pi plus 4 minus 12 over pi r third power equals 0. First of all, you will get rid of this pi r to the third power. So every term you multiply by pi r to the third power. Here's pi r to the third power. Pi r to the third power. So you will get the 2 pi square r to the third power plus 4 pi r to the third power minus 12 equal to 0. This is a power form equation, so I add a 12 for both sides. You will get the 2 pi square r to the third power plus 4 pi r to the third power equals 12. Then factor this r to the third power. You will have 2 pi square plus 4 pi r to the third power equals 12. Then you divide it by 2 pi square plus 4 pi, both sides. You will get the r to the third power equals r to the third power equals 0.371. Then you do the cubic root both sides. You will get the r equals 0.719. For the exam, you don't have to show the work like this. You just see we work through equation solver on the graphing calculator. So you will write down by equation solver in JDC. That's a graphing calculator. We got r equals 0.719. Let's go to 11F. The lobster trap is designed so that the length of the steel used in its frame is a minimum. Calculate the value of L for which T is a minimum. According to 11B, we have L equals 1.5 pi r squared. We already got from 11E R equals 0.719. So we plug in 1.5 over pi times 0.719 squared. You will get, answer will be 0.924 meters. For 11G, the lobster trap is designed so that the length of steel used in its frame is a minimum. Calculate the minimum value of T. We know T equals 2 pi plus 4 R plus 6 over pi R squared. We know this R equals 0.719, so we plug in 2 pi plus 4 times 0.719 plus 6 pi times 0.719 squared. You will get, answer will be 11.1 meters.